Welcome to all. This is just an information class or a details for the upcoming course, analysis of statically indeterminate structures by three displacement methods or the basic displacement methods, namely slope deflection method, moment distribution method and Kani's method. I will explain it later why these methods are important. First, about the course. Course will start from 13 December, that is from today around 2 weeks, December 2022. Class timing will be 7:30 p.m. to 9:30 p.m. Tuesday, Wednesday, Thursday, Friday. Weekly 4 classes. So weekly 10 hours, 2 into 4 is 8 hours class will be there. I need around 45 to 50 hours. So that is around 25 classes. So by end of January or starting week of February, course will be over. I will tell you, actually I need around 40-45 hours. Extra 5 hours I kept, I will tell the reason. Now, I will not again and again tell now. Those who want to register, or if you want more details, one brochure I will send. I made a brochure ready. You either call my number or send message through WhatsApp. If you want details, you send details and mention your name. Or if you want to call personally, you can call this number. And information, this course will also cover the requirement of 5th semester BE, Structure Analysis 2 or Theory of Structures, where these three methods are major part of the syllabus. Okay. Now, come to subject now. One more thing, come to subject this side. Slope deflection method is the basic method for structural analysis by displacement method. I think you know a method called matrix method, matrix stiffness method. Using that one, we got finite element method. For all those methods, slope deflection method is the basic. Now, why you require to study this one, or why you should know these methods? Reason, simple. See, suppose you consider a continuous beam. Just briefly, just not much, only 2 members. See, after analysis, some loading will be there. You get the moments here, I will put moments separately. You get the member end moments. See. Member end moment like this. Here what will happen? Suppose this comes to 26.9. This also will come 26.9. Both are in kilonewton meter. Suppose you draw bending moment diagram. I don't know relative values here. If I am not going to superimpose now, I am going to draw the actual bending moment diagram, so that is actually above to draw by superimposing principle. That I will do later for academic purpose. I don't know what type of loading, something like this. Imagine UDL. Okay. It's a bending moment diagram. Now, this moment and this moment will be equal. So, the BM here will be 26.9. Now you can see top tension here, hogging BM, here sagging BM, hogging BM. Accordingly, software will give the result. People know how to see the result and go for detailing. Now, actually, practically, these two moments will not be equal. See, because here we have taken a simple rigid support. Suppose you take a frame action, see, building frame. There, if I will call here ABC. Suppose I take the same member ABC here. Then, see, for member ABC, there will be end moments. A, B, B, C. Suppose here, this way. These two will not be equal because for equilibrium here, this moment, this moment, this moment and this moment, all 4 together will be in equilibrium. Algebraic sum of all the 4 values will be 0. So, suppose you got 26.9 here, you may get 21.8 here, 31.6 here. The difference of that one will be for the columns. Further, I will not tell. That all will come in the methods. See, these are all important because when you see the result by software, you can see the steel requirement. For example, here top steel requirement, this side member, it will show 818 mm square. It will tell some other value here. Say for example, If it is this type of beam, it should give 18 only here. But if it is this frame, it is not 21.8, it's okay, 121.8, 131.6. Then it may give you 965 mm square. Some people, what they will do, oh, they will take the higher value, correct. But why it came, that all will be covered by this method. We will cover continuous beams, simple continuous beams, and frames also. Frame means even including sway effect also will be there. And at the end, so that you learn thoroughly the understanding of indeterminate structure analysis by displacement method. So that meanwhile, you will be knowing the terms called flexural stiffness, carryover factor, all those things, rotation of rigid joints, displacement of joint, everything will be covered. And at the end of the course, what I will do is, I will take a frame of this type of frame. Limited, see, manual design or manual analysis, a frame of this type. This I will analyze by, not by all three methods, not possible. See, I told maybe around 45 hours required. Last 5 hours I will keep for this one. You can do only by Kani's method. It is a very fast method. So we will solve it by Kani's method. Then in front of you only, I will use software, preferably ETABS, and analyze the same frame by ETAB and compare the result. Result will tally. So then you will be knowing correctly how the result in the software comes. So purpose of this course is to understand how statically indeterminate structures are analyzed or how it behaves. That is the main purpose. Now, this class I told will start from 13th December. Another maybe 2 weeks are there, nearly 13, 14 days are there. But remember, there are some pre-requirements here. If you want to solve, analyze by any of these methods, pre-requirement is calculation of fixed end moments for different loading conditions and also support settlement solve. That actually comes in other chapters, analysis of fixed beam. So what I have done is, see, in my channel, YouTube channel, KSN Structural Engineering Classes, you go to playlist. There, I have made so many playlists there, RCC design, BSK classes, etc. You see indeterminate structure, recent playlist. There you can see BSK class 214. That is because it is the 214th class for basic structural knowledge. People are coming from right from beginning, from engineering mechanics. Or indeterminate structures, it is class number 6. Class number 1, 2, 3, 4, 5 are for propped cantilever fixed beam analysis. That will not come here. So if you want, you can study, or what you can do is, you learn class 6 and class 7, just already uploaded. 1 or 2 more class I will upload tomorrow and day after tomorrow. So that this class 6, 7, 8th tomorrow, if required 9th, that will be 214, 215, 216, 217 is the pre-requirement for this course. How to find fixed end moment, see, for central point load, WL by 8, for UDL, full span, WS square by 12, all those things are covered there. So anyway, those who join the batch, for them, I will tell in the starting class, I will take one extra class for them. Before this Tuesday, that is 7:30, 13 December, or on that day, I will inform them how much they have studied the previous classes. Very systematically here, it is shown. So go through that one. Others also can go through it. And regarding the fees for the course, in the class I don't mention it, you get it in the brochure. But one thing, it will be a very, very reasonable fees. That's all. Further, I don't want to talk. Okay, now you contact me for details or admission, and class will start from 13th of December. Okay, thank you.